Hello everyone, in this video let's discuss how to solve the approximate traveling salesman problem. In this we are having two types of problem. First one is nearest neighbor and another one is twice around the tree. Now in this video let's discuss about the nearest neighbor, and the twice around the tree video link will be given in description. You can access it. Now there will be a given graph or the paths. In the traveling salesman problem, what the salesman will do? The salesman will start its journey from a city. Let us call it as A. And then he will go to all other cities, and then he will come back to its home city. Again he will come back to the city which he started. So he must move with the least cost. That is, the cost of moving from one city to another city must be least, and another is he must return back to his home city. Return back to his home city. So apply this one to the given graph. So the first step will be finding the source router or the source city. So you can consider any of these nodes as the source city. So I will be considering A as the source city. A as source node or source city. Now since we are applying the nearest neighbor algorithm, A is considered as the source router, no? So first find nearest neighbor. I will be writing NN. NN means nearest neighbor of A. Nearest neighbor of A. See the diagram. From A you can go to B. From A you can go to B. From A you can go to D directly. From A you can go to C directly. So if you see the cost from A to C, so you write here. From A you can go to B, you can go to D, and you can go to C. So the cost of moving from A to B is 1. And the cost of moving from A to D is 3. The cost of moving from A to C is 6. Now among these 1, 3 and 6, which is the smallest value? 1 is the smallest value. So what was our aim? Our aim was to find the least cost path. So what I will be doing? I will be choose the path from A to B, A comma B, with the least cost of 1. Now I am arriving at the B city. Now find the nearest neighbor of B city. From B you don't want to go back to A, because once all the cities are completed, then only you can go to the source city. So from B you can directly go to C, and from B you can go to D. From B you can go to C and D. Cost is from B to D it is 2, and from B to C it is 3. So the least cost is 2. So choose B to D with the least cost of 2. Now we are at the D. Next, find the nearest neighbor of D. So you can't go back to B, you can't go to A. So you can only move to C. So C is the only left, and from D to C the cost is 1. So you will be choosing C only. So now choose D to C with path cost of 1. Now you came from A to B, from B to D, from D to C. All the routers, all the cities are completed. Now you will be going to the home city. So again choose C comma A with the cost of from C to A it is 6. So you started from A as the source city, and you traversed all the city, and you came back to your home city. Now let's find the path cost. So the path cost is from A you went to B with cost of 1, plus from B you went to D with cost of 2, plus from D you went to C with cost of 1, plus from C you went to A with cost of 6. So 1 plus 2 will be 3, 3 plus 1 will be 4, 4 plus 6 will be 10. So I got the value as 10. 10 is the least cost. So now again I will be finding whether any another possible path is there to travel in the least cost. Now if you see, From A I went to B, from B I went to D, from D I went to C, from C I went to A. So this is same as from moving from A to C, C to D, D to B, B to A. Same, because the path cost will be same itself. Now whether another possible condition is there? Yes. From A I can move to B, from B I can move to C, from C I can move to D, and from D I can move to A. A to B, B to C, C to D, D to A. Find the cost. From A I can move to B, from B to C, C to D, from D to A. Find the cost. From A to B, the cost is 1 plus. From B to C, the cost is 3 plus. From C to D, the cost is 1 plus. From D to A, the cost is 3. 3 plus 1 is 4, 3 plus 1 is 4. So 4 plus 4 is 8. Now if you see, I got the least cost of 8. Here I got the least cost of 10. So what I will be doing is, find the approximate value. So the approximate value will be equal to 10 divided by 8. In the nearest neighbor, I got the value as 10. While finding the another shortest possible path, I got it as 8. So if you find, it will be around 8 divided by 10 means 8 ones are 8, 8 twos are 16, 1.2. So you got the values in the points or the decimals. So this nearest neighbor is not that much accurate. So we will be using the twice around the tree algorithm. So the video link of that video is given in description. You can access it. If you have any doubt in this nearest neighbor algorithm, please comment below. I will try to solve the problem. If you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.